All right, in ALEKS there is a topic titled Solving an Equation with Positive Rational Exponents. And so you're going to get a question that looks like this, and they ask you to simplify it as much as possible. So that means we're going to need to write this. We're not going to find an approximate answer. We need to find an exact answer and simplify as much as possible. So what we're going to need to do is we're going to need to undo this exponent. Okay, so we can undo this exponent by raising each side of our equation to the reciprocal of the exponent. So 3 over 2, its reciprocal is 2 over 3. And if we do something to one side of an equation, we have to do the same thing to the other to keep things equal. Now 3 over 2 times 2 over 3, when you remember the rule here, when you're raising an exponent to a higher exponent, you multiply these two together. So 3 over 2 times 2 over 3 gives you 1, and that's the whole reason we did that, because these cancel each other out, and it leaves you with t minus 10 on this side. Now that leaves us with 9 raised to the 2/3 power. So we could think of that as the cube root of 9 raised to the 2nd power. Remember, this bottom number is your root, and this one is your exponent. Okay, so here when I look at this, can I take the cube root of 9? No, 9 is made up out of 3 times 3, right? So I can't simplify that any further. So what I'm going to do is I'm going to look at this as 9 squared and then take the cube root of that. So 9 squared is 81. So can we take the cube root of 81? So I'll put that here. That's what this, we'll put that over here. And then we're going to simplify this. So 81 is 9 times 9, and 9 is made up of 2 3s. So we basically have 4 3s here. So to take something out of the cube root, we need 3 of the same number multiplied by itself. So these 3's will combine together to come out of the cube root as a 3. And this 3 will stay on the inside. Okay. Oops, and I need my little 3 there to show that that's the 3rd root of 3. Okay. Now we just need to solve this the rest of the way. Over here we need to get t by itself, so we add 10 to both sides. We get t equals 3 times the cube root of 3 plus 10. Okay. Now this is our answer. We can always check our solution, and also I want to talk to you about a couple different different cases. So if you noticed up here, my exponent in my original equation was an odd number. Okay, so when that happens, you're just going to have one solution. Okay, and if this is an even number, I could have more than one solution. Okay, and I'm going to explain why that is in just a second. But I just want to show you, if I wanted to check my answer, what I would do is I would take this value right here and plug it back into my equation for t. So I'd be taking 3 times the cube root of 3 plus 10, and that's what t equals, minus 10. If I raise that to the 3 halves power, does that give me 9? Now I just want to remind you that this right here, 3 times the cube root of 3, that was the cube root of 81. Okay? So you could write this as 81 to the 1/3. So I'm going to write this as 81 to the 1/3. And here, plus 10 minus 10, those cancel each other out. So 81 to the 1/3 times raised to the 3 halves power. Okay? So if you do that, that makes this a lot easier. And then you can multiply these two together, and that gives you, you can 3 over 6, which becomes 1/2. So this is 81 to the 1/2 power. And the square root of, means the square root of 81, because that's my root, which is 9. And that's your check. So if you want to check these, you can do that. But I'm going to show you two things to be careful for. So just before I do that, I want to explain this part. If I have x squared equals 25, when I solve this, when I take the square root of both sides, you actually have plus or minus the square root of 25. A lot of times in geometry when you did this, we just skipped the negative possibility because you were talking about distances. And so we just kind of just took the square root and just considered the positive and answer. Okay, but technically it could have been a positive 5 or a negative 5. Okay, so that's what plus or minus means. You have two solutions, 5 and negative 5. So I want you to think about that. X could have been positive or negative. When I squared it, it made it positive. Okay, so when I have something like this, where this value is an even number, you're going to need to consider that you could have a plus or minus solution when you square root or you take the root of both sides. Okay, and that's essentially what we're doing here. I know it doesn't look like we're taking the square root, or the fourth root or anything like that. So if this was an even number, I would have put a plus or minus right here. So let me give you an example of a problem like that. And then we'll have one more case to look at so that you have all three kind of things to look for. So this is an even number, this part right here. So when I raise both sides to the 3/2 power, I'm going to put a plus or minus out here in front of that. Okay? And that was because that was even. This value right here. Okay. So now on the left side, 2/3 times 3/2, that gives me 1. Those cancel out, gives me z plus 6 equals plus or minus, and I'm going to simplify this to the third root of 2 squared. Oops, I just did that backwards. This is my root. So the second root, square root of 2 to the third. So when I have a square root, I don't necessarily have to put the 2 there. It's assumed if there's nothing there that it's a square root. So this is going to, I'm just going to come over here to the side. 2 to the third is 8, and I want to take the square root of 8. I want to simplify that. 8 is 4 times 2. Okay. So these 2's, there's 2 2's will come out as 1 2, and 1 2 will stay inside the square root. So this is plus or minus 2 times the square root of 2. Okay, now you're going to subtract 6 from both sides. Okay, so what you have are two answers. 2 times the square root of 2 minus 6, and a negative 2 square root of 2 minus 6. Okay, and those are your two answers for z. Okay, and remember you can always go through and check those and see that both of them work. But I want to talk about one more case here, and that is when this is equal to a negative. Okay, and this is an even number. Okay, so I want you to think about that. If this right here is an even number, when I have a value, no matter whether x is positive or negative, when I raise it to this even power, can it ever be a negative? So if I had the square root of 2 squared is always going to be a positive 2, right? Or even if it was a square root of a negative 2, when I square it, I get a positive 2 back, right? There's no way for it to be negative. So in this case, when you see that, it's no solution. Now, if this was a power like an odd number, like 3, right? Then I could have a negative over here. Because if I'm raising something to the third power, so a negative 2 to the third power is a negative 8. I can get a negative back. Okay? So it's just when this is even and that's equal to a negative that you're going to have no solution. If you go ahead and you actually solve this problem when you check it, okay, then you'd find that it's not a solution. But it's a lot easier to notice that at the beginning of the problem.